Everyone, welcome to the introduction to JSON for the CASSINI Hackaton edition, Connecting the Arctic. We have with us today the co-founder and CEO of Rokubun, Xavier Banque Casanovas. And Xavier will tell us more about JSON, a precise location post-processing cloud service that you will be able to use during the hackathon. Xavier, very much welcome to this session.
Hello, thanks, Thomas. Good evening to everyone.
Before we get started, I just want to tell the participants that there is a Q&A button at the bottom of their screen, and they can ask any questions to you during the session, and I will address them with you after your introduction. So I just wanted to remind everybody that they can ask as many questions as they want to you at the bottom of their screen through the Q&A screen. So Xavier, without further ado, I'm very keen to learn more about Rokubun and about JSON.
Okay, so yeah, thank you so much, and welcome everyone to this CASSINI Hackathon webinar. Thanks for inviting me, first of all, and thanks for adopting JSON technology as one of the technologies made available for the hackathon participants. So I'm going to try to let you know a little bit what JSON is about. But let me start with a brief introduction about Rokubun. I don't know, probably none of you knows about Rokubun. Rokubun's a tiny company. It's an SME or a startup, whatever you want to call it. It's been running for roughly 6 years now. And we deal with satellite navigation, right? I guess you know what satellite navigation is. And at Rokubun, we focus in what we call accurate and affordable navigation, which is some sort of a new niche, a new market segment in satellite navigation, targeting those applications, those verticals that are in need of accurate or precise navigation. But yet, at the same time, they do require the solution to be affordable because they need it to be scalable, right? Because probably they have lots of users, or it's an application in the mass market, or it's an application for which the operations entail short budgets. I don't know, for instance, drone operations, right? And that's the niche where Rokubun is developing satellite navigation-based technology, with a mission of providing solutions that get the best of mid-end and low-end hardware, providing performances that a few years ago were typical from high-end equipment. And our vision is essentially to democratize precise navigation or precise location for mass market applications. So that said, I'm not gonna bore you with corporate presentations. Don't be afraid. I'm gonna let you know about JSON, which is a tool you're gonna have available for this next not this weekend, but the next one, hackathon. JSON is a cloud PPK service, right? Don't know up to which level you guys are acquainted with GNSS and the classical precise GNSS techniques that exist, but I'm gonna go through a brief introduction about it. So GNSS satellite navigation has a few traditional techniques for what we call precise navigation. So typically, precise navigation, it's the one that provides errors in the order of 1 meter or less, right? So when we have a navigation or location solution that provides a level of error under 1 meter, so decimetric error, we can talk about accurate or precise location. In order to get this kind of performance, classical GNSS, classical satellite navigation is not enough, right? So we have to rely on what we call precise navigation techniques. There's two big families of precise navigation techniques. The RTK or differential techniques families, and the PPP ones, the precise point positioning technique for precise navigation. They have differences. The main differences is that the differential techniques, they do rely on an existing infrastructure for which the location is known with precision, and up to which we rely when doing differential positioning to get our receiver positioning in a very accurate manner. Whereas on the PPP side, there's no need, or in principle, because that's not really true, but there's way less need of infrastructure, because PPP is based on receiving a stream of corrections that our receiver applies together with the gathered measures and gets as well accurate results. I'm not going to enter into the details of which are the strengths and weaknesses of each of the techniques. Obviously, none of them is good for all the applications, right? But JSON is what we call a PPK cloud service. PPK is the post facto or post-processing version of the classical RTK techniques. So JSON is a cloud service that performs precise navigation based on differential phase or phase differential techniques. When applied in real time, they are called RTK, from real-time kinematics. But when applied in post-processing, which is the case of JSON, they're called PPK, post-process kinematics. Okay. In addition, JSON allows as well to process PPP, precise point positioning, but we do normally recommend to try as the first option PPK, because it normally provides better accuracy results, okay, and shorter convergence time. So, in essence, JSON is a tool with which you guys, with which users gather GNSS data with their own hardware, with platform agnostic, and this hardware can be classical GNSS receiver, namely, I don't know, uBlocks families or ST families or a Septentrio receiver. It can be any kind of receiver as long as it gathers data in standard formats, which most of them do. It's what we call the RINEX format. But it can be as well a smartphone, right? It can be as well an Android smartphone able to gather GNSS raw measurements in the Android format. We support this format as well. In the Q&A session, if you want, I can point you to a good reference on which are the Android terminals supporting this technology. And then once the user uploads data into our service, let me remind you, this data is GNSS observables or GNSS measurements. JSON automatically does its magic, and it fetches the best processing strategy given the data uploaded by the user, and delivers precise navigation results. If the, I don't know, if the rover was in a static position, JSON results going to be 1 point, 1 coordinate, lat, long, height. But if the rover was, I don't know, in a dynamic scenario, a car or a drone, or I don't know, whatever, a guy riding a bike, it will provide a precise trajectory. And that's in essence what we do, right? And then you might be wondering why precision, why accuracy matters, right? Why accuracy is important. Well, standard GNSS solutions, they do provide geolocation estimations or trajectory estimations in the order of in between 2 and 5 meters in good condition, and in harsh environments that can be even higher. We can be talking about 10 meters of error. Okay, so I guess you will imagine that for the case of, I don't know, surveying something, for a G surveying, for a surveying intending for an inventory of some, I don't know, public facilities in a city scenario, an error of 10 meters, it's not enough to properly geolocate assets in a city, right? I mean, you cannot geolocate, I don't know, a bus station 10 meters away from where this bus station is actually, right? So that's why accuracy matters. I think we can now proceed to the demonstration so that you see what JSON looks like. So I'm going to share my screen. I feel being quite boring. I'm sorry for this. This kind of webinars.
No, I think it's good that we got a little bit of an introduction to the different types of more precise navigation that there is available, because we have participants from all that are very experienced in GNSS, but others don't know about it. So it's good that you gave us an introduction.
Okay, so yeah, I mean, one of the good things about JSON, can you see my screen now? The landing page of JSON?
Yes, we can see it.
So one of the strong points of JSON is that it's super easy, right? It's conceived to be easy to use. It does not require from the users any kind of GNSS specific expertise, right? So it's been designed and developed so that it's a drag and drop philosophy. I mean, you don't need to have any special insight about satellite navigation to use it. So that's the landing page of the service. In this landing page, there's a couple of useful things. Probably the first one is the tutorial. It's the video tutorial, which I'm not going to show you now because you can do that offline. But it's a good introductory video. I think it's less than 1 minute, so that you have a clear idea of what JSON's doing. Essentially, that's more or less what I said. JSON's the cloud PPK service, which is fully automatic. Its final goal, or it aims at improving satellite navigation accuracy or location accuracy. In this case, JSON, it's very tailored for drone operations. And this event synchronization, it's a feature that focuses on drone mapping operations. And it's cloud, right? So users do not need to download any software, nor to be updating versions, etc. Right? And your user interface can be accessed from anywhere in the planet, right? As long as you have internet connection in a browser. That's a very important feature as well. That's the coverage of the PPK service. As I said, PPK is a technology that relies on an existing infrastructure, an infrastructure of what we call core station, continuously operating reference stations, which are GNSS receivers somehow spread around in the globe, whose coordinates are known with a super accuracy, and whose data is publicly available. So we use those stations. We have more than 7,000 stations worldwide. We use those stations for the precise processing of our users' data. Okay. So within this map, you can check prior to your operations whether the zone you're going to operate is covered or not by our service. So the good news is that if it's covered, that's it, nothing else to be said. If it's not, anyhow, the service allows you not only to upload your receiver data, but to own your own base station, and then to upload at the same time the rover and the base station data, and it will anyhow compute this precise location out of those sources of data. Then another very strong point, especially concerning hackathons and potential future of projects born in hackathons, it's the API. So JSON has an API. The user interface and the front end, it's only for a kind of customers, but JSON is very oriented to be integrated within bigger processing pipelines. And that's why we have an API. It's a very easy to use API for which you have available online documentation. You can check it here. And this API, it aims at integrating JSON in whichever your processing pipeline is. So what we're going to see in the demonstration in a few seconds can be done via the API. Okay, exactly the same. It has the full functionalities of the service via the API, and that's it. That's a couple of testimonials, as in any software as a service website. So let's go. Let's sign in. Obviously, I have my user and my account. For the hackathon, Jason is a freemium service, so you can use it for free up to a certain level of usage. And during the hackathon, you'll be enjoying our 14-day trial, which means that you can use the service full-fledged during 2 weeks. No constraints on the number of epochs processed, etc. And so that's what the service looks like.
Xavier, maybe just for participants, so there's a link on the tools page of the Hackathon website that links to Jason, and then they can just register for the trial, right? Like there's no special steps to be taken.
No. Name, I think it's name, surname, email, and probably.
And they can get started.
Yeah, that's it.
Sounds easy enough.
Yeah. So yeah, it's easy philosophy. No, just kidding. So that's what user interface, the main page of the user interface looks like. So that's the 2 main services you can have access to with JSON. I'm going to start with the minor one, and I'm going to demonstrate you the major functionality. The minor one, that's rather geek, but it's useful at some point. It's a GNSS converter. So GNSS observables, they might come in different formats depending on the receiver that has been used to acquire them. Okay, so you have a service here which is called GNSS converter that is very useful to transform whichever the format is to the standard of the industry, which is the RINEX file. Okay, so this is very easy to use. It's a drag and drop. It's just drop here your GNSS measurements file. You have here the input of the supported input list. So it can be u-blox receiver, Septenter receiver, Android GNSS logger, which is the Android, etc. And then you convert this, and then you get back a RINEX file. But what we're interested in is the PPK processor, right? Which is the service with which you get precise geolocation data, either a single position or a trajectory. So as I said, it's a pretty easy philosophy. You just have to drag and drop your data. I obviously have my data ready here. Let me try to not. So I have here a file which I'm drag and dropping, and yes, I have it here already. So I drag and drop my RINEX file. You see .RINEX. This is a file which was captured by one of our receivers, Argonaut receiver, mounted in a drone. That's a drone flight. If I'm good in my memory, so let's see at the end of the processing if I'm right or not. But as far as I remember, it's a drone flight. Therefore, we're gonna fix this in dynamics, so the rover dynamic. Since I know it's a drone flight, it's a dynamic, so we want to process a trajectory rather than a position. But if you'd be processing a position, it would be static. And we're going to try PPK, which is the best option out of the 3 you can choose, right? The PPP, if you know in advance, because you check the coverage map, that you're not going to be within our PPK coverage zone, you can choose PPP. But PPP has a set of constraints. And probably the biggest one is that for PPP to be really precise, roughly 48 hours have to be elapsed from the time you acquire your data to the time you process your data, because PPP depends on ancillary corrections data, which is available roughly 2 days within a delay of 2 days. Okay. Anyhow, we're going to choose PPK. We're going to say here, we're going to put a name for the process, Cassini test, and that's it. Okay, I don't have to care about anything else. As I said, if you have your own base station, you can upload data here. And if you are a drone operations guy, and you've been doing your drone mapping mission, drone mapping field operations, you can upload here what we call events file, which is provided by the major drone manufacturers in drone mapping vehicles, in drone mapping UAVs, and you can provide the images that have been acquired by the drone flight here. But anyhow, that's not the case. We're going to keep it simple for the demo. Then you launch the process, and then error when sending the file to the server. Outstanding. Let me check what happened. Am I properly connected?
It's always when you do a live demo, then that works 100 times, and not a live demo it doesn't.
Okay, let's try to drag and drop another file. Let me check the size of this one. 106 megabytes. That's not gonna be. What about this one? Okay, let's try this one. I'm gonna drag and drop another one. So let's try now. It's a strange name, but let's see what it pops up out of this. I have no idea of what we're processing, so we'll see whether it's a drone or a car drive. Let's see. I mean, at Rokubun, we've been working with several use cases, drone operations, automotive, I don't know, hiking for pedestrians, whatever. So then you launch the process and you can forget about it. You can go backgrounds, you can close the service, whatever. But if you don't, there's it's the service. It's some point it has some verbosity level, and there's those logs here that tell you what's going on, what the service is doing. Then so look, the service has detected 185 events. That's probably images acquired within a drone flight. The service has found that there's a nearby core station which is going to be used for PPK processing, and then it tells you the position of this reference station, and it's telling you that the baseline in between you and the rover it's only 10 kilometers, which is fine as long as you are within 50 kilometers. If you're using a dual frequency, or 25 kilometers if you're using a single frequency receiver, you're going to be able to have PPK results. Then the service is telling us that he's processing data in the PPK technique, which is the best results you can achieve. In this case, you see 25 kilometers here of maximum, because that's a very simple and low-end receiver. It's a u-blox M8T Argonaut. Rokubun's Argonaut receiver is embedding a u-blox M8T, which is a single frequency multi-constellation receiver, so it's rather simple. Then soon it's still processing. You see this. That's a short processing. Processing is normally taking between 2 and 20 minutes, depending on the size of the data uploaded. That was 14 megabytes processing, which is an average, I would say an average processing. You can process up to 250 megabytes. So now the service is telling us GNSS processing was successful. It's preparing the results. And then once it's ready, you can click on the show results button, and then you are directed to the results page, in which you see what your results look like. Okay. Then you have in the right side of the screen of this interface, you have a sort of a report of what's going on, of what happened, right? You have the classical number of satellites plot. So that's the number of satellites which is being used in the processing, and the sky plot. For those acquainted with satellite navigation, you know exactly what I'm talking about. This is a time series profile of the height of the drone. Mm-hmm. And those are technical information about, okay, which been the first epoch process, last epoch, the duration of the flight. You have as well the number of events detected. And then you have the result files here that you can download. But you can as well download all the bunch of files, of resulting files within this button here. And you can see the logs, which is what we've been looking at in real time. You can see the summary here. Then,
what are the different colors that we see on the field?
That's very good.
The different tracks?
Sure. So different tracks which can be somehow enabled and disabled using those buttons here are the events. Those are the detected events by JSON. So those are the images that the drone took during the flight that have been detected and accurately geolocated. So that's the final product in this case of JSON, because those accurately geolocated events can be directly fed into a photogrammetric processing tool for precise ortho results. Then you can choose PPK, which is the precise trajectory of this drone, which looks somehow bizarre, but that's what it is. So we have some jumps here. That's probably lots of luck. And finally, you have the SPP, which is the indeed field trajectory. So that's essentially it. That's what the service looks like, and that's how JSON has to be used. Then finally, to end up in my processes, you have a summary of all the processes you've undergone so far. You can retry some processing. You can see the results of former processing, and you can, I don't know, you can download data of, I don't know, that's one of my former processings. That was a DJI, another processing with a drone in a UK construction facility. And yeah, you can see exactly the same. You can see the precise trajectory, the events, and that's what it is. I think I'm done on my side. I'm ready for Q&A.
Okay, great. What is the ideal way to work with your service for the participants? You mentioned there's an API. We saw you now in the demo using the tool. How should they best work together with JSON?
Well, I would say let's start using the UX, the user interface, the front end, because there's no need to go through the documentation to give it a try. But then once you know what this service can do, and then you somehow have an idea that involves using the service, then it's worth having a look at the API documentation so that you can somehow integrate JSON in your service. Okay.
So you'd advise the participants to start with the UX, and then they can see if it works in their processes to switch to the API. I have a question from the audience. How does JSON compare to the high accuracy service of Galileo?
Well, that's a very good question. This guy knows what he's telling, or girl. Very easy. So HAS, it's what we would say, well, it's not what we would say, it's a PPP. HAS, high accuracy service from Galileo. It's a stream of PPP corrections. It's a stream of orbit, clocks, and biases corrections, which belongs to the PPP family. PPP, according to our experience, will never be as good as PPK in case you can choose, right? We are working in the integration of HAS into JSON. So sooner than later, HAS will be as well available as one of the processing options in JSON. And the good news about HAS with respect to current PPP is that there's no need to wait those 48 hours to have access to the precise correction stream, because HAS is already very good quality correction. So we will be able to have PPP in near real time.
Okay, great. Andre is asking us, can you tell us more about the base station, about this reference station that we also saw when you were going through the processing?
Yeah, sure. I mean, base stations are I don't know. Let's have a look at the states. By the way, California is a very good example. You still see my screen, right?
Yep.
Okay, California, as you might know, has very active tectonic activity, right? And that's why it is packed with GNSS core stations, because public authorities, they use GNSS core stations for the monitoring of tectonic activity with the aim of generating early alerts of earthquakes, etc. So we somehow leverage this public infrastructure in order to provide this differential data for the PPK processing as a function of where the guy where our users are operating. So what the service is doing is, the first thing the service it does is to undergo a first processing in order to understand where this data is roughly geolocated, and then to fetch the nearest reference station in order to recompute again positioning, but in this case, with using differential positioning to achieve best accuracy possible. So they are really important, those core stations for us.
Mm-hmm. Okay, but just to make it clear to the participants, these base stations are either existing. If they would happen to have one, they can add the data to JSON, but it's not required at all to have it. You can just use the ones that you have already access to, right?
Yeah, sure. I mean,
yeah.
as long as you are, oh no, let's guess that you want to operate here close to the border of I think this is Arizona and Mexico, right? So you have this station which is available in our network. Say you are operating somewhere around here. You don't need to care about base station. Don't even to worry about. I mean, the service is gonna do this for you. The service is gonna detect you are in this area, and he's gonna choose P001 to be used as the core station to undergo PPK processing.
Mm-hmm.
But as I said, if you are operating here, you can always bring your own base station and upload it within the service together with the rover data.
Mm-hmm. Okay, understood. And then still talking about infrastructure, maybe not as costly as a base station. You also mentioned that people can just use a smartphone.
Yeah, sure.
And you wanted to tell us which phones they could use. Can we use all phones, or it needs to be a specific phone?
No, you cannot use all phones. It's only Android smartphones that support GNSS raw measurements collection as of today, and only high-end Android smartphones. That's a very good reference. I'm gonna try to share via. Can I use the chat in
yes,
in Zoom?
Absolutely. Yeah.
So I'm gonna share with you now. So you're still looking at my screen, right? So you're gonna see this. This is Sean Barbeau. That's Sean Barbeau, who's a guy active in GNSS R&D. That has initiated. Let me try if I'm able to find. That has initiated some sort of a crowd initiative for identifying which are the Android smartphones able to provide you guys with GNSS raw measurements. I'm not going to find this as easy as I expected, but I'll do so. Hold a second.
For the participants, we'll also make sure that that this list, that's a link, we'll put it also in the website in useful links on the tool page, where, as I mentioned, you can also have access to the link to JSON.
Okay, let's do this, because I'm not finding it now. I had not this prepared in advance. I'm so sorry. I apologize for this. It's going to be better to do this offline.
Sure. And so basically, but just on that website, on that link that we will share, you will be able to see then all phones that have the capability to generate this data that can then go to JSON, and as a result, we have a precise position.
Yeah. I mean, let's bear in mind a couple of crystal clear ideas. Besides positioning with smartphones, it's constrained for obvious reasons by the GNSS hardware embedded in a smartphone, right? The GNSS antenna within the smartphone and the GNSS chipset within the smartphone, they are not as good as those of dedicated GNSS receivers for obvious reasons, right? So you cannot expect the same level of accuracy using a dedicated navigation device when using GNSS coming from a smartphone. That said, there's a few terminals, I would say probably a dozen, that have to comply with 3 conditions. Okay, first one, and I'm talking always about Android high-end terminals, but they have to be dual frequency. They have to provide access to GNSS observation, and they have to provide access to carrier phase observation. So ranges and carrier phase. So if those smartphones you plan to use are compliant with those 3 conditions, you can achieve in open sky conditions, so not in urban areas, you can achieve metrish accuracy, so roughly 1 meter of error, which is fairly good as an horizontal error.
Okay.
When using JSON, I mean, under PPK processing paradigm.
Okay, that's understood. So I think we're already a little bit over time. If any of the attendees have a question, they'll have to be really quick because we'll have to close the session. Basically, your colleague will be with us during the hackathon weekend. So if there's any more questions, they can also be asked during the hackathon when we're welcoming Miguel to the panel. So thank you very much, Xavier, for joining us tonight. The recording will be available on the tools page together with all the links so that everybody can rewatch it or access the links that you mentioned.
Thanks to you.
Thank you very much. Have a nice evening, everyone. Bye-bye.